All right, write this down first, guys, over here on the side. There's 14 questions total. All right, 14 questions total. There's going to be two sections, a multiple choice section and a free response section. So the multiple choice questions are going to be the adding and subtracting of the rationals. Right? Those seem to give us the hardest time. So Mr. Saldana and Ms. Chung and I got together and we thought that would probably give you the best opportunity for success if we made them multiple choice. Kind of give you guys some guidance. There's 5 multiple choice. Of the multiple choice, there's 3 solving rationals and 2 where you're just adding and subtracting. So I'll go through that and talk to you about how to solve and stuff like that. Then there's free response where you just have to do all the work. Of the free response, it's one simplifying, 1 multiplication, 1 dividing, and then 6 where we're solving linear equations. So I'm going to go over all the different types. Anything that's highlighted is what I'm going to do, and then the rest I think is a good idea for you to do tonight as practice. And like I said, I'll post the solutions. I'm not collecting this. You guys do not have to turn this in. But it's probably a good idea if you do it, all right? So these first 2 questions that I have highlighted, what do the directions say to do? Simplify. That means you're going to factor and make smaller. All right, where we are making mistakes still, guys, when I start off like this, can I just cross off the k-squareds? No. Remember, these, if you have plus and minus signs, they are stuck together. You cannot cross off when you have plus and minus signs here. If it says to simplify, this will be one of those free response questions. There's one of them. You're going to have to factor. Factor the top and factor the bottom. When you factor the top, guys, A times C, what are the factors of negative 35 that will multiply to give you negative 35? I'm going to just use x's for all these, but add to give you a negative 2. X minus 7, x plus 5. Okay, again, I know it's k's. I just want to use x's. So then on the bottom, let's factor the bottom. If I multiply A times C, what are the factors of negative 50 that will multiply to give me a negative 50, but add to give me a negative 5? Yep, x minus 10 and x plus 5. Now that you have everything fully factored, do you notice anything on the top and the bottom that's exactly the same? The x plus 5s, those we can cancel out. What are you left with? X minus 7 over x minus 10. You cannot cross out the x's there, guys. X is stuck to negative 7 in the top. X is stuck to negative 10 in the bottom. Those are together. You cannot cross them off. Do y'all see that? All right, another example. Again, if it says to simplify, simplify means factor and see what they have in common. So let's multiply A times C. Negative 35. Again, what are the factors of negative 35 that multiply to give you negative 35 but add to give you negative 2? It's again negative 7 and positive 5. Good. And then on the bottom, 1 times 15. What are the factors of 15 that multiply to give you 15 but add to give you 8? X plus 5 and x plus 3. Do you see anything on the top and bottom that's exactly the same? The x plus 5. So cross off 1 on top with 1 on the bottom. What you have left over is your answer, x minus 7 over x plus 3. The directions say to simplify. You factor everything you can and then cross off what they have in common. You guys got that? All right, let's scoot down then. Now we get into still simplifying, but what are you doing in number 4 and 5? You're multiplying. We're going to factor each and multiply. I'm going to do number 6. If you multiply, all that means, what do you have to do? You factor every piece and then see what they have in common. So 4 is just going to stay 4. K plus 7 will just stay. Can I do anything with this 4? No. Can I factor here? What's k squared plus 8k plus 7? Well, we're going to multiply A times C. So 1 times 7 is 7. What are the factors of 7 that multiply to give you 7 but add to give you 8? Okay, so k plus 7 and k plus 1. So now, guys, is there anything on the top and bottom that's exactly the same? The k plus 7. Is there anything else? The 4. I got a 4 on top and a 4 on the bottom. So what are you left with? K plus 1. That's it. That's it. When you multiply, you factor each piece and cross off what they have in common. What about, some of you got this messed up on your quiz. Right? Say had this. Some of you left it like this, or then you multiplied. Do you see anything you can cancel out? Are either of the parentheses the same? No. But what about if you have 3x's in the numerator and just 1 in the denominator? One of them cancels, right? This x cancels, and this becomes how many? X what? X squared, right? If you have numbers outside, like if you had a 4 on top and a 10 on the bottom, then the 4 and the 10 could simplify. So just be aware of that. All right, so you have a simplifying one for your response. You have a multiplication one. That's all. You're both doing the same thing. You just factor and then cancel out. How is this one a little different? It's division, right? When you divide, guys, you have to keep, change, flip. Some of us forgot to do that, so then the whole problem is wrong. So we're going to keep, I'm going to rewrite it as x squared plus 7x minus 30 divided by 3x squared minus 9x. If you want to change everything to x's tomorrow, go ahead. Then I'm going to change my division to multiplication, and I'm going to flip. So then I have 3x squared minus 9x over x plus 10. And now we're going to factor each piece. I'm going to start in the top left. So I'm going to do it in red. All right, I'm going to multiply a times c. Negative 30. What are factors of negative 30 that will multiply to give me a negative 30, but add what? Where?
On the second top.
Oh, this is a 3? My bad. Thanks. Thank you. Yeah, perfect. Thank you. Sorry. All right, what's going to multiply to give me negative 30, but add to give me 7? Think about 30. You have 1 and 30. You have 2 and 15. You have 3 and 10, or you have 5 and 6. How could you multiply to get a negative 30, but add to get 7? X plus 10, x minus 3. Perfect. Okay, so top left is done. Now let's go to the bottom left. Well, let's do it in light blue. All right, bottom left. What can you take out, guys, of 3x squared and 9x? Okay. If you take out a 3x, if I divide out a 3x here, what am I left with? X minus 3. Good. All right, let's go over here to the bottom left. Can I do anything? Can I take anything out of x plus 10? In the bottom right. Can I take anything out of x plus 10? Right here? Can I do anything? No, so just rewrite it. X plus 10. And then we'll go up here to my top right. What do they have in common? 3x squared and 3x. All right, take out a 3x, and then what are you left with? Write it underneath if you see it better. I'm left with x minus 1. Good. All right, now we've fully factored everything. So you just look for anything on the top that's the same as anything on the bottom. What do we notice? I see an x plus 10 up here and an x plus 10 down here. What else? X minus 3 here, and I have one down here. Good. And 3x here, and 3x here. So that whole problem leaves me with what? Just x minus 1. Perfect. All right, so 3 of your free responses are just right there. 1 is simplifying, where we just factor or cancel out. 1 is multiplying, where you factor each piece, cancel out. And then 1 is dividing, where you have to keep, change, flip first, then factor and cancel out. Sound good? Let's go to the next one. Another kind of problem I just want to make sure that we're on top of. What do we notice? What is this problem? It's division. So we need to keep, change, flip. So I'm going to keep 7x plus 28 over x plus 4 times, and then we flip x squared minus x minus 30 over x squared minus 4x minus 45. We're going to factor each piece individually. I'm going to start up here in the top left. What can I take out of 7x plus 28? 7. If I take out a 7, what am I left with? X plus 4. Good. Now I'm going to go to the bottom left. Can I do anything? Can I take anything out of x plus 4? No, so I'm just going to rewrite that as x plus 4 times bottom right. What are my factors of negative 45 that are going to multiply to give me a negative 45 but add to give me 4? 9 and 5? Okay, so x minus 9, x plus 5. Agreed? You guys with me? Okay, now let's go up here to the top right. Factors of negative 30. What can I multiply? It's going to give me a negative 30 when I multiply, but a negative 1 when I add them. Minus 6 and plus 5. Now that we have fully factored everything, whatever we have in common, let's cross it out. Anything on top and bottom, that's exactly the same. X plus 4 and x plus 4. What else? X plus 5 and x plus 5. All right, so you're left with 7 times x minus 6 on top over x minus 9. Guys, leave it like that. Don't FOIL. Some of you gave me these answers of like x to the 4th and blah, blah, blah. Don't do that. Just leave it fully factored. You're simplifying. Simplifying means make small. Questions? All right, you're going to have 2 multiple choice questions, right? This is adding and subtracting rationals. You're going to have 2 of these questions. You're not solving, you're just combining them. And they're multiple choice. How do we add and subtract fractions? You have to have what? The same denominator. So in this case, I'm going to look and I'm going to say, okay, one denominator is n minus 5, one is n minus 2. Can't factor anything. And then I also notice that this is a minus sign, so I'm going to change it to a plus and stick the minus right there so I don't forget to distribute. We're not solving, we're just adding and subtracting. So we need to get a common denominator. What's my common denominator between n minus 5 and n minus 2? You stick them together. Perfect. N minus 5 times n minus 2. So now we're going to look at each fraction independently. My first fraction in the denominator has an n minus 5. What's it missing? The n minus 2. Perfect. So what you do to the bottom, you do where? To the top. My second fraction has the n minus 2. What is it missing? The n minus 5. So what you do to the bottom, you do to the top. Now all 3 of them have the same. So I'm just going to rewrite the numerator. 6 times n minus 2 minus 6n times n minus 5. You just keep rewriting the denominator, guys. The denominator stays what we figured it out to be. N minus 5 times n minus 2. So now let's distribute that 6. 6 times n is 6n. 6 times negative 2 is minus 12. Negative 6 times n is minus 6n squared. And then negative 6 times negative 5 is what? Negative 6 times negative 5 plus 30n. Now let's rewrite it in standard form and combine like terms. Again, n minus 5, n minus 2 stays underneath. What's your highest exponent you see? Okay, so I'm going to rewrite negative 6n squared. I have a 6n and a 30n. What does that give you? Plus 36n. And then what? Minus 12. All right? That might be an answer choice. That might be an answer choice. But what if it's not an answer choice? What do you guys notice about the numerator? Could you simplify it? All right, they might have it to where it's fully simplified. They might have it where it's not. So you need to be able to recognize both. But what do they all have in common in the top? Can I take out a negative 6? All right, if I do that, that leaves me with n squared. What? Minus 6n? Didn't we get 36? You're fine, you're fine. And then minus what? Or plus? A negative 12 divided by negative 6 is 2 all over n minus 2 n minus 5. So the answer choice could be written either way. Will they have both answer choices? No. It'll either be fully simplified or not. I'm not sure, but just understand that those two things are the same. Yeah.
Why wouldn't you do like you do the minus 6n and the minus 12? You do like C multiply and adds.
You could, but look, once we factor that out, if I multiply a times c, are there factors of 2 that'll multiply to give you 2 but add to give you a negative 6? It doesn't factor anymore. Good thinking, though. Good thinking, though. We're going to get to that point. But those two things are the same. Those are the same exact answer. You just got to be able to recognize it. Yes, ma'am.
Can you go to 13? It's basically the same thing, but the simple form.
Kid, let me finish what I'm doing, and then I'll go back and do it for you. I'm going to work all these out and post them so you guys can see them. All right, look at 14. I chose 14 for another reason. Are they two completely different denominators? No. They kind of have something in common, right? So when it's this situation, I want you guys to look at this. First thing I'm going to do is change this minus sign to a plus and stick that negative right in front so I don't forget. And then I'm going to factor. What does n squared minus 4 factor into? Good. N plus 2, n minus 2. Good. So when now you guys have a denominator where they kind of have some stuff together and kind of have some stuff different. First write down what some of them have in common, which would be what? N plus 2, okay? And then the other one has what in common with one of them? N minus 2, right? So now we're going to see what each fraction has and what it's missing. My first fraction has both. We're good to go. My second fraction has the n plus 2. What's it missing? The n minus 2, right? So what you do to the bottom, you do to the top. And then your third fraction has the n minus 2. What is it missing? The n plus 2. So what you do to the bottom, you do to the top. So I'm going to rewrite my numerator, 5n times n minus 2 minus 2n plus 2. Now our denominator is going to stay the same, n minus 2n plus 2. And we're going to simplify the numerator. So you have 3 plus 5n times n is 5n squared. 5n times negative 2 is minus 10n. Then you have negative 2 times n is negative 2n, and negative 2 times 2 is minus 4. Everybody with me? So now we're going to, again, rewrite your denominator for the 22nd time. Why did I put a 4? And then let's combine like terms. What's the highest exponent you see? Okay, so 5n squared. Now I have a negative 10n and a negative 2n. What's negative 10 minus 2? Negative 12n, good. And then 3 minus 4, negative 1. Now, can we simplify that at all? Is there a GCF or anything in the top? Between 5, 12, and 1? No. If I multiply 5 times negative 1, are there factors of negative 5? Are there factors of negative 5 that'll multiply to give you negative 5 but add to give you negative 12? No. So that's it. So this would be a multiple choice answer that you guys would pick. All right, you're going to have 2 of those. 2 where you're just adding and subtracting. So you got to get a common denominator, and then you can go ahead and pick your multiple choice. Moving along, you have 3 multiple choice, guys, where you're solving rationals. I'm going to be quite honest with you. This is not our strong suit. I know it's not. I know it's not, okay? So some of you are going to have no problem with something like number 15. What is my common denominator on number 15? Between x, 2, and 2x. 2x. You'd say your common denominator is 2x. So my first fraction has the x. What is it missing? The 2. So you multiply this. My second fraction has the 2. What's it missing? The x, right? My third fraction, guys, look, this is a minus sign. So you got to change that and stick that right here. What's going to happen with that minus sign? You have to distribute it. There's a lot going on in that problem. So what you end up having is 2 times x is 2x, plus 2 times 1 is 2, equals 1 times x is x, and then distribute. Minus x plus 6. So we'll combine like terms. On the left-hand side, I have 2x plus 2. On the right-hand side, what happens with x minus x? It cancels. Equals 6. And then I'm going to subtract 2 from both sides. So 2x equals 4. So what's x equal? 2? All right, so here, this is what I want you guys to understand. If you guys are totally confused on these problems, and some of us are still having a tough time, if this is a multiple choice question, what can you do with the answers? You can plug them back in, right? If you get to these and you have no idea where to start, go ahead and think about plugging back in. First of all, what answer could not, x could not equal because it would make my denominator 0? It's the only number that x would be that would make your denominator 0. 0. So if one of the answer choices was x equals 0, you could go ahead and cross it off and be like, oh, that one doesn't work. That's extraneous. The answer here is 2. This is how you would plug back in. You would say, okay, 2 plus 1 over 2 equals 1 over 2 minus 2 minus 6 over 2 times 2. All I did was plug 2 in for all of the x's. So let's simplify a little bit. What is 2 plus 1? So 3 over 2 equals 1 over 2 minus, well, first we got to say, what's 2 minus 6? Negative 4 over 4. What happens when you have minus a negative? What's minus a negative, guys? What do these two become when you have minus a negative? Positive, okay. So if you were going to add 1/2 and 4/4, you have to have a common denominator, right? What's your common denominator between 2 and 4? No. 4. What would you have to multiply your 2 by to make it a 4? 2. So I have to multiply the bottom by 2. Then I multiply the top by 2. So over here I have 3 over 2 equals, what is 2 plus 4? 6. Is 6 over 4 the same as 3 over 2? Yes. If you simplify 6/4, what does it simplify to? 3 over 2. All right. So if you just have absolutely no idea how to even begin a problem like this, just start with the answers. Look at something like number 17. What do you know n cannot equal? No, n could be 2 or negative 2. N can't be 0. Perfect. In number 18, what can a not be? Negative 2. What happens when you have negative 2 plus 2? That's when you get 0. It cancels. So some of these problems are difficult. I understand that. Some of us are having a tough time with this. So use your resources. The 3 that you have for solving rationals, adding and subtracting, it's all multiple choice. So if you have answer choices, plug them back in. Try to work backwards. Again, I'll work all these out so you guys can have the solutions to see. But for those 3, that's what I would do. All right, then lastly, you're going to have, what I say, 5 or 6 solving linear equations. We've got to be able to solve equations, guys. So let's go through these. Look at your left-hand side, look at your right-hand side. Do you have anything like on number 22 that you can combine? Yes, what's 3x plus 4x? 7x equals negative 21. Then I do what? Divide both sides by 7. So x equals, what's x equal? Negative 3. Okay. What can you do with x equals negative 3 to know for sure that you got your answer right? You can plug back in. All these solving ones that are free response, you can plug back in and make sure your answer is correct. So I just want to do a couple of examples. How do I start this problem? And again, I'm going to change this to x's because my b's are going to look like 6's. We're going to distribute. I'm going to leave my negative 120 over here, and I'm going to distribute this negative 5. What's negative 5 times 3? Negative 15, right? X. And then what's negative 5 times 8? Negative 40, and then I have minus 5x. Before you move anything anywhere, guys, keep your negative 120 over here. What can I do with 15x and negative 5x? I can combine. What's 15 minus 5? 10. Okay, so I have 10x minus 40.
Wouldn't it be negative 15?
Oh, I forgot the negative out there. Thank you. Sorry. Oh, I didn't even see that. Thanks. So negative 5, how did I not see that? Negative 5 times negative 3, yes, it's going to give you negative 15. So when you combine here, negative 15x and negative 5x is what? Negative 20x, good, minus 40. And then you guys, you want to put numbers on one side, letters on the other. It does not matter where you move. If you want to move 20 to the left and negative 120 to the right, that's fine. If you want to just take the 40 and say, I'm just going to add it to both sides, go ahead and do that. What is negative 120 plus 40? Negative 80, okay, so negative 80 equals negative 20x, and then we do what? Divide by negative 20, so x equals, how much?
4.
Perfect. And again, what can you do with that 4? You can plug it back in. All right, again, I'm going to change this to x. Before I can start moving things from one side to the other, what do I need to do first? Distribute. 5 times 5 is 25. 5 times x is 5x. I'm distributing a negative 5 here, so negative 5 times x is minus 5x. Negative 5 times negative 4 is positive 20 equals 45, right? Let's clean up. Let's combine like terms. What happens right here with a positive 5x and a negative 5x? They cancel, right? This should tell you something, guys. When your variables cancel, it's one of those special cases. Keep simplifying. What's 25 plus 20? 45, right? So this is either going to be an all real numbers or a no solution. Think about this. When does 45 equal 45? All the time or never? All the time. That would be all real numbers. Whenever you get a true number statement, the number on the left is the same as the number on the right. That happens all the time. That will give you all real numbers. That means any number you plug in for that variable will work. It'll make your equation true. Let's look at something like 29. We'll do 29, 30, and 32, and then we're done. Again, I'm going to change this to x. What do I do with my negative 7? Okay, so negative 7 times x is negative 7x. Negative 7 times negative 1, plus 7, good. Negative 6 times x, negative 6x. Negative 6 times 8. 48, good. All right, combine. Leave 11 over there. I have a negative 7x and a negative 6x. It's negative 7 and negative 6. Negative 13x. And then I have a positive 7 and a negative 48. So it's 7 minus 48. Negative 41, okay. What am I going to do with that negative 41? I'm going to add it. I'm going to move it to the other side. I'm going to come over here so I'm running out of room. So I have 52 equals negative 13x. And then I do what? Divide by negative 13. So x equals 52 over 13, which simplifies to 4. What kind of 4? Negative 4. Good, good, good. All right, look at 30. Anything to do on the left-hand side? No, just leave it as negative 17 plus 7n. What do I do with this negative here? I have to distribute it. Don't forget about that, guys. A negative times a negative is a positive. Then negative 1 times 4 is minus 4 minus 5. So leave negative 17 plus 7n over here. What can I combine on the right-hand side? Negative 5 and negative 4. So I have 7n minus 9. You guys agree? Okay. Let's move letters to one side, numbers to the other. So I'm going to add 17, and I'm going to subtract 7n. So on the left-hand side, what happens? What's negative 17 plus 17? 0. What's 7n minus 7n? 0. Equals, what happens on the right? What's 7n minus 7n? 0. What's negative 9 plus 17? 8. When, guys, does 0 equal 8? Never or all the time? Never. If that is never true, what's your answer to this equation? No solution. Both things are possible. Please be aware of that. If you get a true math statement, 45 equals 45, 7 equals 7, -1 equals -1, that's true all the time. That's all real numbers. If you get something that is untrue, like 0 equals 8, that never happens in the world, so that's why it's no solution. And then the last one, and then I'll stop talking. All right, so 8n over here on the left. What do I do with my -4? Distribute, good. So -4 minus 4n plus 5. 8n plus 25 is still going to hang out here. What can I do with -4 and a positive 5? That's going to combine, right? So you're going to have -4n plus what? 1. Now move letters to one side, numbers to the other. I'm going to go ahead and add 4n to both sides. And then I'm going to subtract 25. So 8n plus 4n is 12n. 25's cancel. -4 and positive 4n cancels. What's 1 minus 25? -24. And then we divide both sides by 12, and n equals -6. Good. All right, that's exactly what you can expect from your test tomorrow. Remember, 5 multiple choice. 2 of them are just adding and subtracting. 3 of them are adding and subtracting with solving, so you can plug your answer choices back in. You have 1 simplifying, 1 where you're multiplying rationals, so we factor all the pieces and cross out. 1 where you're dividing rationals, where you keep, change, flip, factor everything and cross out. And then 6 of these solving linears. Actually, you know what? If you guys had a problem like this, you don't have to write this down, just look. How many of you look at fractions and you're like, oh, I love fractions, they're so easy. We don't like fractions, do we? Okay, that's okay. Does anybody know what we can do to solve this and make it easier on ourselves? How would I get rid of that fraction? Okay, you can multiply, because think about this. This is just a rational, right? What's your common denominator between 3 and 1? 3. If I just put a big 3 right here and distribute it all the way through, you guys can do that. Whatever the common denominator is between any of the fractions, you can do that. This happens to be 3 because they both have 3. But if you were to multiply right here, what's 3 times 2? 6, and 6 divided by 3 is 2. So this gives you 2x. Now I go here. What's 3 times 4? 12, and then 12 divided by 3 is, so plus 4x. 3 times -1, -3 equals, what's 3 times -2? -6. And now you've got rid of all of the fractions. Once you do that, then you're free to just solve like normal. You just, whatever you do to one side of an equation, you have to do the other. So what would you combine here? 2x and 4x gives you 6x minus 3 equals -6. So what would you do to both sides now? Add 3. So 6x equals -3. And then what? Divide by 6. So in this case, x would equal -1/2. If you start off with a fraction, just figure out what your common denominator would be and multiply the entire equation by it. Whatever you do to one side, you do to the other, and then it'll be fine.